The area of a triangle, guys. The area of a triangle, obviously the most famous is 1/2 base times height. That is super important. It is still valid. It is still useful. You will use that for some problems in the section for sure. That being said, if information is given in a side angle side format, where the angle is included between two sides, you have a very elegant, simple formula that can be used. Here's what I'm talking about. Just looking at, say, if we had triangle ABC, and if you had, side A given to you, you also had side B, and angle C was given. Here's your side angle side situation. Look what you can do with trig. 1/2 side A times side B times the sine of angle C. All three letters show up. A, B, and C are showing up. It's just that the third letter, the C there, is showing up as an angle, of course. But most importantly, I hope you can see that it's a side angle side kind of a setup. By way of comparison, you could just as well have written this as 1/2 BC sine of angle A. Notice again, all three letters are showing up. And as a last form, 1/2 AC sine of angle B. No doubt about it, we could even do an official proof that this is true. I guess what I want to show you at some point before we take the test is that B sine C is actually a height. It's actually a height. And tell you what, I might as well do that right now just to make sure you get it. Look, here's a height. And tell you what, because sometimes kids just look at this formula and they're like, okay, if you say so. Right? But look at this. You could say, look at this right here. If this is B and if this is H and this is C, go back to SOHCAHTOA. Do you see what I'm talking about? Go back to SOHCAHTOA. You'd say, oh, the sine of angle C is equal to the opposite over the hypotenuse. In other words, the height is B sine of angle C. All of these forms right here, if you'd say, what's the area of this triangle? Well, it's 1/2 the base times the height. Well, oh my goodness, the base is A. What's the height? We just saw it. B sine of angle C. There's a quick proof. So it's not like this is some mystical formula that just popped up somewhere and you'd be like, heaven knows how it works, but it's true. Well, it's true because it's 1/2 base times height, right? Okay, so here's the beauty of it. Here's the beauty of it. Do number 1 with me right now. Oh my gosh, this becomes so simple. So simple. You'd be like, oh wow, would you look at this? They asked me to find the area of the triangle. It's that beautiful pattern of all three letters showing up. And you'd say, my gosh, even without having to draw a picture, I could just type all that out. Now, if we're really on our toes, we won't even need a calculator. Because what's the sine of 30, guys? Good review. 1/2. Oh, 1/2 of 8 times 6 times another half. Hey, look at that. 2 goes into 8 4 times. 2 goes into 6 3 times. Oh, you'd get a 12. Of course, you could multiply that out on the machine. You'd get the same thing. Doing okay? 1/2 base times height, but beautiful forms with trig. Heron's formula, also known as Hero's formula. I don't know how it was written in your geometry book. I taught out of that book so long and I forget. I always mention both forms. And there's a little blurb here. Since we're making a video, I'll have you read the historical feature. We could even talk about it a little later in class or tomorrow if you'd like. But Hero's formula allows us to deal with side, side, side. Now, of course, sometimes kids will say, well, use the law of cosines and find an angle, and then you can use that formula up above. You bet. But look, an even more simplistic, more elegant form is that if you add up the three sides of a triangle to get the perimeter, And then if you take the semi-perimeter, if you take half of the perimeter, in triangle ABC, if you know all three sides, the area is the square root of semi-perimeter times semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C. Work that out and you're done. Amazing. It even works for like a 3, 4, 5 right triangle and so forth. All these wonderful situations. So with no further ado, let's jump over to number 2. You could say, oh, the area of a triangle is asked to be found. We have sides of 4, 5, and 6. Hey, our perimeter just means add up those numbers. 4 plus 5 plus 7. To say, hey, that's 16. Yep. Semi-perimeter literally means, would you take half of that? And now we can say the area is the square root of 8 times 8 minus 4 times 8 minus 5 times 8 minus 7. And guys, if you would like to get the calculator out and just let it, work everything out for you, you could. That would be fine. Here's 8 times, 8 minus 4. Not that it's all that difficult to, just continue to finish it up. Here's 8 minus 5. And then finally we have 8 minus 7. Work that out, and I guess you get about 9.797 or about 9.8, roughly, as a decimal. If you wanted to work this out exactly, of course, right now you'd have 8 times 4 times 3 inside of that radical. And 8 is really 4 times 2 also. So this 8 is 4 times 2. Here's another 4, here's a 3, and here's a 1. Oh, look, I've got 2 of the same number. How about I pull that out, and I'd be left with about 4 radical 6. And radical 6 is, of course, just a little bit bigger than 2. 4 times something a little bit bigger than 2 would get you 9.8, wouldn't it? So in case someone said, no, I want exact, you could do that as well. Okay, well, hopefully we're doing all right. Got a couple more. These next problems are literally taken from our book. I believe Mr. Clifford picked some later application problems, which I think we can all appreciate, because it's one thing to just do some problems and then later on in your assignment you might think, wow, these problems seem to be getting a little bit more difficult. How do I proceed? What do I do? Well, here's one problem from the homework. See the following figure, the area. Find the area of the shaded region here in a semicircle, diameter of 10 inches. And the length of PQ is 8 inches. Well, I'm looking at this, and I hope you're remembering that if you have a triangle inscribed in a semicircle, what do you know about angle Q? It's going to have to be a right angle. Sometimes kids are like, ooh, I don't know about that, if you say so. Hold on a second. So many of you are juniors. You're going to be taking the ACT. The ACT is 30-some% geometry. Yikes. Okay. You might remember that, here, I'll make up any old angle. Let's just say that we have an arc of 100 degrees. Hey, what's the angle of this inscribed angle that we have here? Remember, you take half of it? Oh, here's half of a circle, 180 degrees. You take half of the 180, you get 90. Right? So that's why you're guaranteed to have a right triangle. Oh, wow, let's see here. 8 and 10. What are some of our Pythagorean triples? The most famous is 3, 4, 5. Double everything. Oh, my word. Would you look at that? That missing side is 6 from a 3, 4, 5 right triangle. Wonderful review for not just a trig class, but to help you out on standardized testing in general. But, hey, more to the point, sometimes kids look at this and they'll say, well, Hey, you know what? We weren't asked to find QR. They didn't ask us for that leg. They want us to find the area of the shaded region there. What do? How do you think we could find that? Area of a half circle minus the area of the triangle. And that's what your shaded area is going to be. Yeah, the whole thing minus what's been removed. Okay, so the area of a half circle is 1/2 pi r squared. You know what? Here's why I don't want you to ever forget 1/2 base times height. You see how you have the base and the height in this triangle? I mean, you could rotate that and very quickly see that, wow, yeah, I've got my base of 6, I've got this 8, yeah, my hypotenuse is 10, but wow, this hopefully isn't that big of a deal. 48, half of 48 is 24. Wow, what's the radius of this semicircle? 5. So I'm going to go 1/2 pi 5 squared, and that's 25 pi over 2. And guys, might not be the prettiest looking answer that you're going to have, but there it is. That's the area of the shaded region. We doing okay? Mr. Clifford put this last one on. Very thankful that he did. Because as you get into the very tail end, some of the problems aren't as routine. They're not quite as quick and simple. You got to maybe work a little bit more. And as we read this, to approximate the area of a lake, a surveyor walks around the perimeter of the lake, taking measurements shown, and using this technique, what is the approximate area of the lake? Rest assured, what we're about to do will be working with triangles. Working with triangles. Very quickly, I think kids are going to correctly point out and say, hey, wait a minute, I'm not getting the real area of the lake. I might be getting too much. Like, I'm going to call this Roman numeral 1. Roman numeral 1 is that first triangle. And if I took the area of that triangle, kids will correctly say, hey, you're including some area of grass in there. That's not part of the lake. Agreed. But this is an irregular shape. We have to come up with some way to at least approximate it. So we can take a look at triangle 1. And we can say, well, oh, would you look at the side angle side given information? Sometimes kids are like, so? Guys, that's at the very front page of the notes. 1/2 AB sine of angle C fits that perfectly. Hey, this is delightful. The area of that first part is 1/2 35 times 80 times the sine of 15 degrees. We don't even have to label that with letters. We could find that area nice and quickly. Now, Roman numeral 2 in the middle is going to be the most challenging, unfortunately. Let's deal with number 3 momentarily because I think that's easier. Sometimes kids are like, no, it's not. I don't have the information that I'd really like to have. I'd like to have an included angle. I'd like to know this angle inside here. Oh, well, what is it? 80. It's the supplement. And we could once again say, well, this is nice. It's side angle side information. Wow, sine of 80 degrees. And hey, we are well on our way. And then kids will say, oh, yeah, everything's looking good. But hey, Mr. Dobner, number 2, Roman numeral 2, I'm at a loss. I don't know what to do. I don't have an angle. And frankly, I'm missing some sides. Let's find them. Let's find them. Maybe we could find some sides. We'll call this X. Working with triangle 1, could you find out what X is? with the law of cosines. If I call this y, working with